Okay, team, this should be the last video that you watch before I come back to school. Woohoo! So, we are going to talk about factoring using the distributive property. Now, factoring, if you remember, is pulling things apart. We're breaking them down into all their different little pieces that would multiply together to make the big number. So for instance, just as an example, if we are going to factor 8, we're going to break it down into 2 and 4, and then 2 and 2. This would be the prime factorization, 2 cubed, right? 2 times 2 times 2. If we were to list the factors of 12, we would say 1 and 12. 2 and 6, and 3 and 4, right? Those are factors. Those are numbers that multiply together to get 12. So when we say we're factoring using the distributive property, it means that we are breaking things apart according to multiplication and division. All right, so a review of the distributive property. When you have a term on the outside of parentheses, in order to simplify this expression, you can distribute the 2a to the 6a and then distribute the 2a to the 8, right? Because this is on the outside, you have to distribute it to both of the terms on the inside. So if you were to do this problem, you would take the 2a times the 6a, and you would get 12a squared, right? And then you would do 2a times the 8, and you would get plus 16a. Okay? So now, this is the distributive property. This is not factoring. Factoring takes things apart. Distributive property puts them together. So when we go this direction, we are distributing. And it's actually when we go this direction that we factor. So we use the concept of the distributive property to help us think through factoring, but distributing and factoring are actually opposites. One goes this way, the other goes this way. So because we're using the distributive property as our framework for factoring, we're asking ourselves when we look at an expression like this, we're saying first, the distributive property already happened here. There was a number on the outside, whatever that was. There were numbers on the inside, and whatever number was here on the outside has already been distributed to those other quantities. Now, your job as this mystery solver is to figure out what number went here and then what two numbers filled in the insides. Now, the easiest way to think about this is if this number was given to this and to this, and it ended up with this as the answer, then that means this number and this number both have to have this in it. So whatever number this is, these two numbers both have to have it in common. This is where we bring in the greatest common factor. Because if these two both have to have it in common, you might as well pick out the biggest one you can, right? So distributive passed out a number, factoring takes it back. I'm taking it away. So what can you take away? What can you divide both of these numbers by? Well, their GCF for the numbers is 4. And if you look at their A's, each of them have at least one A. So we're going to put an A on the outside. Now, if for distributing, we passed out the 4A, for factoring, we're going to take it back. So if we take back 4a from 12a squared, we would get 12 divided by 4, which would give us 3, and a squared divided by a, which would give us a. Then we would also have 16a. We need to take this 4a back from 16a, and 16a divided by 4a is 4. So now we have our binomial factored into a monomial and a binomial. This and this are factors of this expression because when you multiply them together, they end up giving you this expression. Now please notice here that there are actually 3 different factors that we end up with. The 4 is 1, the a is 2, and this whole binomial right here is the 3rd factor. So if you were asked to list the factors of 12a squared plus 16a, you would say 4, comma, a, comma, and 3a plus 4. 3a plus 4 is the last and final factor. It's all one group. Okay, let's try another one. Again, this problem we're assuming has already been distributed to. Whatever number was on the outside, it's already been passed out, okay? So we have to figure out what that number was at the beginning and what the 2 numbers were that were distributed to. What was hanging out in the parentheses before it received this quantity right here, okay? So whatever was passed out is now in both terms. What is in both terms? Here we have a 9 and here we have a 36. Well, both of those are divisible by 9. So let's put a 9 there. X squared and x, they both at least have one x. So we can put an x out front. Now this is the term that we have decided was distributed. So before it was distributed, what was this first term here? 9x squared divided by 9x would have given us an x to start with. And then we go over to this term, 36x divided by 9x would have given us a 4 to start with. So now here again, we have 2 factors. 3 factors. We have the 9, we have the x, and we have x plus 4 as our 3rd factor. Here's another one that's a little more complicated. We've graduated to 3 terms, but the concept is still the same. Whatever number has been distributed went into all 3. So what was that number at the very beginning? That's the question. So we need to figure out what number divides into all 3 of these terms. Well, 18 and 12 are both divisible by 6, but 9 isn't. So we're going to have to go a little smaller. What about 2? Nope. There's also 3, and that works. So we're going to say that our 3 goes out here. We also need to look at what letters we have in common. This one has a C, this one has a C squared, this one has a C. So they all have at least one C. This one has a D squared, this one has a D, and this one has a D. So they all have at least one D. So before this term was distributed into all these terms, what were they? Well, we can figure that out by dividing. 18cd squared divided by 3cd. 18 divided by 3 is 6. C divided by C is 1, so those cancel out, so we don't put any C's. D squared divided by D is D. We're going to put a plus sign since that's what we have in our original expression. And then we're going to move on to the second term. What is 12c squared d divided by 3cd? Well, 12 divided by 3 is 4. C squared divided by c is c. And d divided by d is, again, 1. So we're not going to put anything there. They cancel each other out. Okay, then we're going to move on to our third term, 9cd. And we're going to divide again by 3cd. 9 divided by 3 is 3. C divided by c is 1. They cancel. D divided by d is also 1, so those cancel as well. We're going to keep our second plus sign. And now we have our factored form. This time, though, we actually have 4 factors. 3 is a factor, c is a factor, d is a factor, and then this entire trinomial is a 4th factor. So 6d plus 4c plus 3 is 1 factor. Okay, but what if you don't have a GCF? For instance, in this problem you have 4ab plus 8b plus 3a plus 6. Okay, so they don't have any variables in common all the way through. These two have a's, but these two do not. These two have b's, and these two do not. And they also don't have any numbers in common. These two, well, actually these 3 are divisible by 2, and this one's not. These 2 are divisible by 3, and these 2 are not. So there is no GCF that goes all the way through. So what we're going to do now is a method called 2 by 2, where we group them in groups of 2. So we're going to put parentheses here and parentheses here. And then, instead of finding the GCFs all the way through, we're just going to find GCFs of these pairs. So for the first group, their GCF is 4. They both have a 4 in common. And then they also both have a B. So out front, we're going to put 4b. And then what's left inside the parentheses, once we've taken out 4b, here is going to be a. And when you take out 4b from 8b, you are left with 2. Okay, so that now you have factored the first group. Okay, then you're going to factor the second group. What do 3a and 6 have in common? Well, they have 3 in common. Then you divide. 3a divided by 3 is a, and 6 divided by 3 is 2. Okay, so you remember how earlier in the video I was saying that when you factored these expressions, you actually had this was a factor, this was a factor, and then this whole binomial was a factor. Okay? Well, here we have 1 factor, 2 factor, 3 factors. And then in this group, we have 1 factor and 2 factors. So we have 3 factors here and 2 factors here. Now, it just so happens that this third factor and this second factor are the same. So now, between this group and this group, the GCF is a plus 2. A plus 2, a plus 2. So if we want to, and we do, we can take the a plus 2 and put it out front. This takes it away from both of these groups. It's out of this group now, and it's out of this group now. So what we have left after we take it out is we have this 4b on this from this group. So 4b. And then we also have, in this group, we have this positive 3. So now, if you see what we got going on here, we got this a plus 2 is out here just one time. You only have to write it once. And then you have what's left in your second binomial. So 4b plus 3. Okay, so let's try another one of these. This is still the 2 by 2 method, right? There's no factors that any of these have all the way in common. These two both have 5s in common, but these two don't. These 3 have y's in common, but this one doesn't. This one and this one both have 3's in common, but these two don't. So as you can see, there are common factors in these 4 terms, but there's no common factor that applies to every single one of them. So we have to use a different factoring method. So we're going to use the 2 by 2, which the first step is splitting them into 2 different groups. And then we are going to take the common factors out of each group. So for the first group, the common factor is 5y. 5 and 15 are both divisible by 5. Y squared, y, they both have at least one y. So we're going to put one y out front here. And then we have to put what's left in parentheses. So 5y squared divided by 5y. 5 divided by 5 is just 1, so we're going to leave that off unless we absolutely have to write it. And then y squared divided by y is y, so we don't end up having to write our 1 because we have something there. Okay, and then 15y. 15 divided by 5 is 3, and because we have a minus here, we need to move it down here. So we're going to put minus 3. And then y divided by y is just 1, so we're not going to write that. So now we have 3 factors in this group. We have 5y and y minus 3. And all those 3 things multiplied together will give us 5y squared minus 15y. So now we're going to move on to this second group and try to factor this. 4y minus 12, their common factor is 3. I'm sorry, not 3, 4. Okay, and then once we take out their greatest common factor, we have to divide, right, to find what's left inside the parentheses. So 4y divided by 4 is just y. Keep your minus sign from right here. And 12 divided by 4 is 3. That's the 3 that I was trying to write earlier. Okay, now, if we look at these factors, we have 1, 2, 3 factors in this group, and 1, 2 factors in this group. We see that they do have a common factor between the 2 groups. So we are going to take out that greatest common factor and put it right there. Then we cross it off because we've used it, and we can put what is left in their own set of parentheses. Cross them both off, and now you have your final factored form of your answer. Okay, so in summary, we have learned 2 different methods of factoring this section. We've learned that we can take the GCF, which is actually the backwards method of the distributive property. So instead of combining things together like distributive does, we are taking them apart. Okay? And then the 2 by 2 method, which means we're going to group into 2's, right? We're going to group into binomials and then take the GCF of each individual group. Okay? So at this point, Miss Lee will give you your homework and you can start working on that. If you have questions and you're really confused, do the best you can, and we will talk about it tomorrow. Okay? This stuff is important, so I'm going to make sure that you get the time that you need. So please do not freak out today. Just do your absolute best, and at least tell me the GCF for the problems that you do, even if you have a hard time factoring, okay? GCF is something that you are perfectly capable of, okay? Have fun!